Well, hello again, everybody, and welcome to another episode here at Master the NEC, sponsored by Electrical Code Academy Incorporated. And today's episode is another episode in our 2020 preview series where we're looking at some of the changes that are taking place within the 2020 National Electrical Code. Again, remind you, it's still an ongoing process and we still have the nitmans to go, but these changes that we're providing during this series are giving you a heads up on where we're going, and these look like these are changes that are going to in fact take place. So we wanted to kind of be the first to give you some of the sneak previews. All right, and we're going to try to keep them short so that you can enjoy them and not have to watch for a long time. Everybody knows I typically am long-winded in my presentations, so we're just going to kind of give it to you. All right, so first things first, we're looking at a change in 310. Now, 310 was significantly changed as far as the structure. Most of the content didn't change. It's just reorganized into a better flow, if you will. And I think the individuals that did it and worked on it during Code Making Panel 6 did an excellent job in reorganizing it to make it flow. They took the medium voltage stuff out and put it in a new Article 311. In order to be able to have us that really need to focus on Article 310 to really be able to find things in a more logical manner. So that's a good positive thing. So let's kind of look at what we're talking about. So this is the 2017 National Electrical Code. And you'll see that 310.106 talks about the minimum size of conductors. And of course, we're talking about conductive material. And again, stranded conductors. And again, insulated. Okay, so none of that information technically changed. What we have now is a change in the 2020 edition that's going to look more like this. Okay, so it's under 310.3 now. And so again, logical format of moving through the requirements, the minimum size, conductive material, stranding, and then moving on into the construction specifications. Okay, and so it's just making it a little easier to look at. Nothing significantly changed in this one. That's why we'll keep this video pretty short. There is some things that I like to call out to people just because I get these questions all the time. The minimum size conductors. The minimum size conductors for voltage ranges up to and including 2,000 volts shall be 14 AWG. The minimum size for the circuit conductors that we use within the National Electrical Code. This has nothing to do with applications in 725 where we might have signaling and control. Okay? All right, so this is 14 gauge copper, 12 gauge aluminum. And again, copper clad aluminum is in here, remembering that just because it's copper clad, it's still an aluminum product. Okay? It's still aluminum. The copper is just the molecular bonding of the outer coating, but it's still considered aluminum. Always keep that in mind. All right, conductive material. Again, hasn't changed. Aluminum, copper-clad aluminum, or copper unless otherwise specified. Okay? So you notice the or. So again, these conductive can be aluminum or copper-clad aluminum, or unless specified otherwise, it's to be considered copper. It's important if you're taking an exam, you know that we're always going to consider copper unless it states otherwise. Solid aluminum conductors. Now here's a weird part. A lot of people think that aluminum for these smaller 12 gauge and 10 gauge is not allowed anymore. Just because they don't make it or manufacturers don't produce it in branch circuit sizes doesn't mean that the NEC says you can't do it. We just choose to not do it. Whether it's the stigma from back in the late 60s to early 70s, which was more about the termination issues than it was about the material, even though that was an old aluminum 1350 series, whereas now it's got to be AA, that's aluminum alloy of 8000 series, okay? And you'll see that as it states in here. So I get that a lot. People say, well, I want to do something like a URD and a 1350 type aluminum, which is fine for outside of a building, fine for distribution around, say, neighborhoods and whatnot, carrying it from a transformer pad to the meter on the outside of a building or something like that. Very adequate. But when it comes to penetrating into the structure, then it's got to be 8000 series. Now, it also goes on, and remember, the NEC deals with that, premise wiring applications. So solid aluminum conductors 8, 10, and 12 shall be made of AA 8000 series electrical grade aluminum alloy conductive material or conductor material. Okay, so we could produce it if we wanted to as a manufacturer, not a problem. Now, it also goes on to say stranded aluminum conductors 8 AWG to 1000 kcmil marked as RHH, RHW, XHHW. Again, also remembering this would include all variants of that, which would be like XHHW-2, which we've learned in previous videos that -2 just means it's okay to use it for adjustment and corrections from the 90 degree, whether it's wet or dry. Ultimately, you're still going to be bound by the terminal limitations of 110.14c. If you didn't know what that was, you need to go watch our video called Derating Demystified. I'll explain all that have to do with terminations, and we have a video for that. You do see that there is an XHHN in there if you've never dealt with it. Again, it's the same cross-linked polyethylene, but it also has a nylon covering on it. And you see all these different types again. THWN, the variant THWN-2 would be fine as well, fall within the scope. Service entrance type U or style U, style CR shall be made of 8000 series, electrical grade aluminum, conductive material. Okay, so when we're dealing with aluminum conductors in these sizes from 8 all the way up to 1000, for example, we're dealing with stranded, and it has to be the AA8000 series. Again, there is two different series. There's a 1350, and then there's the 8000. These are the typical conductors of the aluminum alloy that we typically use, okay, for electrical. 1350 you most notably see because it has good tensile strength, not such good ductile. In other words, it's once you start bending it back and forth, it generates heat. It can snap very easily, whereas the 8000 series is very much comparable to copper as far as its ductile strength and ability to flex and things like that, okay? So you see that the code allows it, but even in the 8, 10, and 12 for aluminum, but most manufacturers don't produce it. If they were to start it, it wouldn't be a violation. It just typically would be faux pas, and most places wouldn't accept it. It also goes on to say for copper-clad aluminum conductors, it says the copper shall be a minimum of 10% of the cross-sectional area of the solid conductor for each strand of stranded conductor. So they have rules they have to follow if you want to use the copper-clad aluminum. Again, it's aluminum, as it says here. The aluminum core of a copper-clad conductor shall be made of 8000 series. So you can't get away with the fact that it is still aluminum. The ampacities that are associated with it are all there. It's all given in the code. And incidentally, it's also all the ampacities in the 2020 code, we're all going to revert back to 310.16 again. So that's your table. But there is, and you'll see this in an upcoming episode where I'll show you what has changed with the ampacity tables and how you would utilize them for the 2020 code. Okay, so just kind of keep those things in the back of your mind. We are dealing with a reorganization, if you will, of how the code is laid out in Article 310. And it is a logical format, and it is for the better, trust me. All right, so stranded. Again, it says we're installed in raceways. Conductors 8 and larger shall be stranded, okay, unless specifically permitted or required elsewhere in this code to be solid. Now, what are we talking about? Well, sometimes you're going to have what's called grounding electrode conductors, and you're going to put them in a raceway for protection. Of course, that would be solid. If you had to put these conductors solid 6s or solid 8s inside of a raceway for physical protection or whatever the code might require later or elsewhere in the code, then it's permitted not to be stranded. But your general circuits that you're going to run out for branches or feeders, and they're dealing with 8 and larger, then you're going to get into stranding. It's easier to pull in the raceways. Less issues of potential sidewall damage because the solid conductor is more rigid, and as it goes around those 90s or whatnot, it could potentially cause sidewall damage to the conductor's insulation, and that would be something we don't want, whereas a stranded is a little more flexible, obviously easier to pull, so it makes for a better installation, okay? And plus the code tells you here in 310.3c that it has to be stranded when it's 8 larger. Again, doesn't matter aluminum or copper here, it's just broad. Insulated. D, lastly, says conductors not specifically permitted elsewhere in this code to be covered or bare shall be insulated. Well, we have obviously equipment grounding conductors that are allowed to be covered, bare, or insulated, and that would be in 250.118 as an equipment grounding conductor, gives you these allowances. Equipotential bonding, for example, in 680 allows for the bare 8 to be run around the perimeter, whether it's in a new grid format. We have a video on that talks about the changes to the equipotential bonding grid when it comes to the perimeter. Go watch that video if you aren't familiar with pool grids and what's coming up in the 2020 code. But that's just examples where it could be bare or even covered other locations. For example, it does allow you to be able to do like an SER would allow you to have a bare equipment grounded conductor in there. And so that's an example. In fact, that would be constituted as a covered because it's inside of a sheathing. So there's other allowances. Again, another example of this would be the equipment grounded conductor that's inside of NMB, non-metallic sheath cable. It's allowed to be bare. Doesn't have to be insulated. Could you insulate it? Most absolutely you could insulate it, but it's not required to be. Okay, so really this episode was just to show you that the information's not gone. I'm just trying to help you know where to locate it now. And so it's going to be in 310.3. So hopefully you got something out of this change. Again, we're going to look more at the changes in 310 because we want people to be more familiar with the flow of what's happening in 310. And you're going to see that it is a much more logical format and how it flows. And we're excited with how people are going to be able to use this to maybe get the installations done more accurately and more code compliant. All right, guys, until next time, hope you enjoyed the episode. Stay safe. God bless.